This is section 8.2b. So we're going to start off with a little bit of review of our central angles and arc measures. So first, I'm going to zoom into number 1. So we want to find the measure of arc BEA. So BEA. So a couple things to remember. We have vertical angles here and vertical angles here. So if this is 56, this angle is 56, this angle would be 56, and this arc would also be 56. Okay, that's because those angles are congruent, so the arcs are congruent. And then we can find CD in here. So we can do 180 minus 56 minus 87, because we're going to minus these two angles, and we can get this one in the middle. So we get 37. Okay, now we have enough information to find BEA. So BEA, just take all of these and add them together. So 56 plus 56 plus 37 plus 87. So we get 236. So that's our answer. I'm going to write it kind of below the line just because it printed weird. And then remember, whenever we have this little m here, we know we're going to be finding a degree. Okay, so then we want to find the measure of JM. So our arc JM, that's this one right here. And then we know in this right angle, that's 90 degrees. So now we have enough information for our circle. So the whole circle is 360. So our equation is 4x plus 1 plus 7x minus 4 plus 42 plus 90 is all equal to 360. Now we want to combine like terms. So combine your x's. So 4 plus 7, we get 11x. And then combine your constants. So 1 minus 4 plus 42 plus 90. So all that together is 129. Okay, now we have a nice two-step equation. So subtract 129 from both sides. So 360 minus 129, we get 11x equals 231. Divide both sides by 11. We get x equals 21. But the question asks us to find the measure of our arc JM. So now we got to take our x and plug it in for JM. So 7 times 21 minus 4. So we get the measure of our arc JM is 143 degrees. Okay, next one. So find the length. So that means we're going to be having to use our arc length formula. So we need the arc length formula. So first we need to find x and we need to find r. So in this, see how 13 does not have a degree symbol? So 13 is our radius. So this segment was 13. And then our r, well, we want our x. That's our degree. So PQS, PQS. So that's 180 plus 72. That's 252. Okay, so this is the 180 and this is the 72. That's where those two numbers come from. Now we have everything we need to find our arc length. So we use the cursive L for arc length. So we have 252 times 2 pi r, which is 13, all divided by 360. When you plug this in your calculator, use your parentheses, okay? Use your parentheses. So we have parentheses 252 times 2 pi times 13, parenthesis, all divided by 360. So I get my arc length to be 57.2. And then if we had units, we could add units. So if this will happen to be inches, then we can have inches here. But in this case, we didn't have a unit. Okay, that was just a little bit of review. Now we are moving on to area of sectors. So a sector is a portion of a circle bounded by a central angle and its intercepted arc. Think of a sector as a slice of pie or a slice of pizza, okay? So the area of a sector is a fraction of the entire area. So instead of getting the area of the whole thing, we want just the area of the shaded part. So we want just the shaded part. And then here is our formula for area of a sector. So again, your x is your degree measure of the arc. Your r is your radius. And then you should notice right here, pi r squared, that's your formula for area of a whole circle, pi r squared. So when this helps us get the area of just that shaded region. So we are using this formula for these problems. So if you need to pause to write these in, but I'm going to zoom into number 1 now. And we do these problems, we want to round to the nearest tenth. Okay, number 1, BC. So BC, that is our radius. Our x is that 51 degrees because that's our arc measure. So now we have enough information to use our formula. So we have our formula is 51 times pi 16 squared all over 360. So again, when you're typing in your calculator, I like to type it all in at once. So here's what it looks like when you type it in. Hold on, my calculator's being weird. Okay, so if you have this Numworks app on your phone or your have your regular calculator in front of you, this is how you type it in. So you have parenthesis 51 times your pi times 16 squared, and then my end parenthesis, and then I divide everything by 360. So here I get my decimal, I get 113.93. So then make sure we round correctly, so that's 113.9. And then it is area, so we need units. So we have feet squared. So remember with area, we have units squared, so feet squared. Okay, PQ. So we have our x is 139 degrees. PQ, that's our radius, so 22. Now we have everything for our formula. So we have 139 times pi times 22 squared, all divided by 360. So type it in, 139 times pi times 22 squared, all divided by 360. So I get 587.1 centimeters squared. Because remember, we're rounding to the nearest tenth. YZ, So that is our equals 9. That's our radius. And then our x is for the shaded region. So to get that, we do 360 minus 42. So x is 318 degrees, because that's we want the shaded part, guys, not the white area, the shaded. So now our formula, we have 318 times pi times 9 squared. I'll divide by 360. So 318 times pi times 9 squared divided by 360. So we get 224.8. And then units squared, so inches squared. Okay, number 4, ST, that's our radius. And then our x is 29 degrees because this little arrow is pointing to the inside of the shaded. So we have 29 times pi times 32.5 squared. I'll divide by 360. So 29 times pi times 32.5 squared divided by 360. A lot of this is just calculator work. Once you get radius and your x, you're basically just plugging it in. So it's 267.3 feet squared. Okay. Number 5. So we got to remember vertical angles are congruent. So these are both 46. So the degree of the shaded region is 46 plus 46. So x is 92 degrees. HG, that's 7. That's our radius. So now we have everything we need. So 92 times pi times 7 squared, all divided by 360. 92 times pi times 7 squared, divided by 360. So we get an area of 39.3 for both of our shaded regions together. And then our units, so centimeters squared. Okay, so what do we notice about JM? JM, that is actually our diameter. So it goes across the whole thing. So 10 is our whole diameter. So that means that this is 180 degrees because of the diameter. And our radius, if the whole thing is 10, then the radius would just be 5. So JN is 5, MN is 5. And then for our X, we just have 58 plus 180. So X is 238 degrees. So we want the 180 from our shaded region plus the 58 for this region. Now we can go ahead and plug it in our formula. So 238 times pi times 5 squared divided by 360. 238 times pi times 5 squared divided by 360. So our area of the shaded region is 51.9 millimeters squared. And that is it for our notes. So if you need anything, here's the whole thing. Go ahead and pause to get anything you missed.